Stop whatever you're doing for a moment and think about this. Where are we going? I don't only mean you or me. I mean our planet and the entire solar system. We've been traveling through space for eternity, but does this journey have any aim or destination? The solar system is moving at a speed of 450,000 miles per hour. Our beautiful blue Earth is snugly tucked inside it, and it seems that our region is quite calm and safe, not like some terrifying experiences our celestial neighbors go through. But where are we going? Just wandering around in a giant circle? Not really. Apparently, our galaxy, as well as several nearby galaxies, are being pulled toward a certain region of space. It's about 150 million light-years away. And the worst thing is that we do not know what exactly it is. That's why we call it simply the Great Attractor. This bizarre area is, unfortunately, on the other side of the Milky Way. That's why we can't see it. This region of the sky is known as the Zone of Avoidance, and it's part of why the Great Attractor is so mysterious. This zone lies in the general direction of the center of our galaxy, and there's too much dust and gas there for us to see far in the visible spectrum. But astronomers can see enough to understand that our galaxy, as well as nearby galaxies, are all moving toward the Great Attractor. It means that something must be making things hurtle in that direction. Could it be a gargantuan black hole hidden in the darkness of the cosmos, pulling things toward it and munching on them? Or is it something even stranger and more dangerous? What we know for sure is that this something is immensely massive. For the first time, evidence of the existence of the Great Attractor was discovered in the 1970s. At that time, scientists didn't have the needed equipment to see through the zone of avoidance. That region blocks most of the visible light coming from beyond. But the good news is that this gas and light can't block all infrared and X-ray light. So when X-ray astronomy became more powerful, people got the opportunity to sneak a peek at objects dwelling in that region. It turned out there was a huge supercluster of galaxies in the region of the Great Attractor. It's now known as the Norma clusters. This enormous structure, consisting of thousands of galaxies, has a mass of around 1,000 trillion suns. So, the Norma cluster is massive. That's true. And local galaxies seem to be moving toward it. And still, it doesn't explain all the movements in that region. And now, I'll tell you something even more puzzling and spooky. The mass of the Great Attractor, whatever it is, isn't enough to account for the pull. If we take an even larger region of galaxies, it will become clear that both the Great Attractor and local galaxies are moving towards something even larger. This space behemoth is known as the Shapley supercluster. It's made up of more than 8,000 galaxies and is as massive as 10 million billion suns or even more. This supercluster is the greatest galaxy cluster we know about within 1 billion light years. And everything in the universe, Earth, the solar system, even the Great Attractor, are moving toward it. But at the moment, astronomers are still trying to find more information about the Great Attractor. The Hubble Space Telescope is now focused on the region of space where it resides. The largest galaxy visible in the region of the Norma cluster is ESO 137002. It's a spiral galaxy with large clouds of dust across the galaxy's bulge. Unfortunately, Hubble, being an optical telescope, can't see a tail of glowing X-rays extending out of the galaxy. And in general, observing the Great Attractor is difficult at optical wavelengths. The plane of the Milky Way both outshines and obscures with dust many objects located behind it. And even though we can get some information thanks to infrared or radio observations, the region behind the center of the Milky Way remains an almost complete mystery.
Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage, recorded by scientists, may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you – a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, moo-moos. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Ring-a-ding-ding.
Look at these two pictures. At first glance, one might think, well, aren't they showing the exact same thing? Truth is, they don't. But both these subjects are some of the most complex structures humans have ever had the chance to study. The first image shows a cluster of galaxies from our universe. The second is just a small neuron in the human brain. After seeing these images, some were quick to compare them. Is the universe nothing more than a huge brain? Now let's not get too excited. Before we go into describing all the similarities between the universe and the human brain, there is something we need to be aware of. It's a little thing called apophenia. And it's when our brains make up similarities between two objects that are seriously unrelated. The best example is when we look at clouds and start to see all sorts of cute animals and weirdly shaped objects. We might be doing the same thing when looking at those two initial pictures. Maybe it's just our brain making up similarities where there aren't any. Some scientists became fascinated with this huge brain universe idea. They wanted to make sure it was not just a weird coincidence. There had to be a way they could measure how the universe compares to the mushy organ inside our heads. So they started with the brain. It's probably one of the most complicated things we know in the whole universe. That's because it's packed with more than 80 billion neurons. These cells are responsible for taking information from our senses and sending out messages all over our body. Try to think of neurons as workers in a factory. They don't just do their work, they actually communicate with each other, thanks to these elements called axons and dendrites. The axons are responsible for carrying electrical signals away from the neuron's body to other neurons or muscles. Dendrites, on the other hand, have the task of receiving that information. All of them together make this mega network of about 100 trillion connections. The universe is one big social network itself too, but this time it's made up of galaxies. You might picture the universe as stars and planets with a ton of empty space between them. It's not quite right. What we can see and measure is known as the observable universe, and it's really vast. Think about 90 billion light-years across, containing hundreds of billions to maybe a few trillion of galaxies. These galaxies, like the one we're standing in at this very moment, are bundled together in groups. Our Milky Way is friends, in a way, with galaxies like Andromeda and Triangulum, and altogether, they're a family called the Local Group. This family of galaxies is part of an even bigger bunch called the Virgo supercluster. From what we can tell, the space between them might not be empty. It's filled with these threads made up of regular matter, but there might also be this mysterious dark matter doing its thing. Scientists didn't stop there. They decided to take it a bit further. They started by examining thin slices of the human cortex, the part responsible for our thoughts, memories, and even our consciousness. The next step was to compare them with equally thin slices of the universe from a computer simulation. Now it's obvious there's this enormous size difference between the brain and the universe. But the way they looked at it kind of made them somewhat comparable. As they zoomed in, think 40 times magnification, these scientists began noticing that the structures were very much alike. At this zoom, the brain's neural network looked like the universe's galaxy clusters. To make sure they weren't just imagining things, they used two clever methods. The first one looked at how these networks connected and how densely packed they were. They noticed that the middle part of a neuron, or its nucleus, is way tinier compared to its connecting fragments. Likewise, galaxy clusters are tiny when you look at the super long connecting threads between them. The second method was about checking how organized these networks were versus just being random. They looked at how everything was structured around each connection point, whether it was a neuron in the brain or a galaxy cluster in the universe. The resemblance doesn't stop there. We know that our brain is mostly water, about 70% to be precise. Now the cosmic web in space, it too has about 70% of something, only this time it's dark energy. Water and dark energy may not be the most important elements in each of their structures, but they might still play a part in how everything sets up. The analogy continues. You see, the space we'd need on a computer to map out the universe is almost the same as our brain's memory storage. Somewhere in the ballpark of 2.5 petabytes. So theoretically, a chunk of the universe could fit in our brains. Or flip that, and our entire life's memories could get stored in the universe's network. There are differences too, and we have to be aware of them to make sure we're assessing things properly. For starters, the universe is pretty much the same all over. It doesn't change its composition that much, regardless of where you travel in the observable area. But our brain, not so much. Different parts have different jobs. Also, our brain connections send information depending on things like what you're seeing or touching. On the flip side, the universe's links are just energy. There's also a difference between how these two structures came to be. It turns out that the patterns we see when we're gazing up at the stars are all shaped by gravity and some weird unseen force called dark matter. Massive fireworks in space called supernovae can also affect this cosmic wallpaper. On the opposite side of the spectrum, our brains got their shape from evolution. That long process where animals, including us, get to pass on the best features and data they've learned to their offspring. So, if a trait like a certain shape of the brain helped our ancestors dodge a hungry tiger, that trait got passed down. Our brains are also built the way they are because they're supposed to act like a superhighway for our thoughts. Quick thinking was crucial for people back in the day when they needed shelter from wild animals or the elements. Now, especially if you're a fan of sci-fi literature, you might be wondering, if the universe is like this immense brain, what might its body look like? We might as well be living in someone else's head. We like to think of humans as evolved, intelligent, and at times, hard to understand creatures. But what if we're just tiny neurons in a larger, more complex structure? Well, for the time being, we can only let our imaginations run wild. There's no way we can test at this point what's outside our universe. By all means, we don't even know how large it is. By looking at the parts we can see, the estimations are that the universe is about 95 billion light-years in diameter. Even if we'd somehow manage to travel at the speed of light, though that seems a bit impossible at the moment too, it would take an enormous amount of time to reach those supposed edges of the universe. There's also the theory of the multiverse. We don't have much tangible proof of this idea either, but it does claim we live in a universe out of many. Ours has time and space. Other worlds may have different rules and components. Life may look differently out there in ways we can't even understand. Having a better understanding of the universe is just as important as figuring out our brains. You see, we still have many unsolved mysteries right here under our noses, or behind our noses to be more precise. There are a lot of things we've yet to figure out about the human brain, like how we store and retrieve memories. We know that each time we learn some new piece of information, our brain changes. But we don't have the entire process mapped out, and it looks like it might take a while before we fully understand it.
Let's test to see how many spiral-shaped objects you can find around you right now. I'll bet there's more than you think. A spiral may be hidden in the flower petals of your houseplants. One might be staring at you from that seashell you brought home from your last trip to the beach. If none of these objects sound familiar, you might want to head over to the mirror and turn to the side a bit. In case you haven't noticed yet, even our own ears are shaped like a spiral. Why does Mother Nature seem to have such a preference for this shape? Many theories wish to explain this weird behavior. One of them is based on the Fibonacci sequence. This Italian mathematician didn't really care much for spirals initially. He was studying rabbits when he came up with this theory. Fibonacci came up with the sequence as a solution to a problem involving the growth of a population of rabbits. Let's recreate his experiment. If you put a pair of rabbits in an enclosed space, how many pairs of rabbits will you find there after a year? To solve this problem, Fibonacci proposed some conditions for his theoretical experiment: that all rabbits are born as a pair, one male, one female. Also, the rabbits can start reproducing after 1 month. More so, each pair of rabbits produces one pair of offspring each month. And lastly, none of the rabbits kicks the bucket at the end of the year. Now, using these assumptions, Fibonacci noticed the following sequence: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. The first two numbers in the sequence, 1, 1, represent the initial pair of rabbits. The next number, 2, represents the number of pairs of rabbits after the first month, one pair of the initial rabbits plus one pair of offspring. The fourth number, 3, represents the number of pairs after the second month, 2 pairs of the initial rabbits plus one pair of offspring, and so on. He soon noticed that his series is made out of numbers in which each number is the sum of the previous two numbers. A lot of other mathematicians have looked at this sequence over the years. They were soon surprised to discover that this system was found in many natural structures, such as the arrangement of leaves on a stem and the arrangements of seeds on a sunflower. If you don't understand why it is so, then grab a piece of paper and a pen. Together, let's try to draw the Fibonacci spiral. You'll have to start with a small circle at the center of your page and then draw larger circles around it without lifting the pen from the paper, using the numbers from the Fibonacci sequence. For example, the first circle is 0 units wide, the second circle is 1 unit wide, the third circle is 1 unit wide, and so on. As you keep adding more circles, they will fit together perfectly to form a spiral shape. The spiral gets bigger and bigger, but it always follows the same pattern based on the Fibonacci sequence. Another famous spiralist was a man named James Bell Pettigrew. He was a Scottish naturalist that became fascinated by the mystery of the spiral shape, which he noticed almost everywhere in nature. He studied it at all scales, from giant nebulae in space to tiny molecules. Despite his research, he couldn't figure out where the spiral came from. He was sure that it couldn't be just a physical thing, and he believed that organs in plants and animals are not only shaped like spirals, but they also work in a spiral way. At the center of lifetime work on this unique shape was the human heart. Pettigrew believed that the heart's spiral structure was the mystery of all mysteries. He also thought this shape was to blame for both its muscular contractions and how the blood seemed to travel within our mighty tickers. The reason why the spiral seems to be everywhere might be really simple: efficiency. Take a look at the basic sunflower, for example. It figured out a way to display its seeds so that it could expose them to the sun equally, without wasting any space and without being limited in their growth. Spiral stairs are another great example too. They just work better. You find it easier to climb them, and they should take less space than the usual ones. We also might be more inclined to notice this shape more than others. That's because a spiral shape, or its proportions, is more aesthetically pleasing to the human eye. It's the reason why interior designers, artists, or illustrators often use these principles in their work. The spiral symbol is also the oldest symbol found in every civilized continent. Some historians believe that the spiral in Asian art may represent the sun, as it has been found on roof tiles from the Tang dynasty near the ancient city of Chang'an. It is also often found at burial sites, and scientists believe it to represent the circle of life, how we pass on and somehow be reborn. This is probably because, in some ancient civilizations, people believed that the sun was born each day, extinguished itself each night, and was reborn the next day. You might have also stumbled upon the spiral as a symbol of hypnosis and dizziness. There's no real evidence that you can hypnotize someone by making them stare into a spiral for a certain time. But its effects on our abilities to focus and our optic nerves are significant. After you've stared at a spinning spiral for quite some time, you'll notice how objects either get smaller or bigger, depending on the direction of the spiral. It's easy to understand why some experience the sensation as hypnotizing. One of the most distinctive features of DNA is its spiral shape. It's also called a double helix. The double helix is formed when two strands of DNA twist around each other, like a ladder being twisted into a spiral shape. This spiral shape is important for many reasons. First, the spiral shape allows DNA to be compact and efficient. The double helix can pack a lot of genetic information into a small space, making it possible for cells to store vast amounts of genetic material in a small area. Second, the spiral shape allows DNA to be flexible and respond to changes in our environment. Because the double helix is made up of two strands that can move relative to each other, our DNA can change its shape. Finally, the spiral shape of DNA allows it to interact with other molecules in the cell. Now, let's look at the big picture. The biggest of them all, that of the galaxies found in our universe. They're also shaped like a spiral due to their rotation and the presence of dark matter. As the galaxy spins, the stars and gas clouds within the galaxy move in a circular direction around its center. This movement creates a spiral shape as the stars and gas clouds are drawn toward the center of the whole system. Additionally, the presence of dark matter, which is a type of matter that does not interact with light, creates gravitational forces that help to shape the galaxy into a spiral. But you don't need to look that far to understand why spirals are important. Your handy corkscrew is shaped like a spiral too, because it makes it easier for you to open the wine bottle. That screw you drilled into the wall to hang a picture, also a spiral. It helps it with some added grip and stability. Got a notebook on your desk? Those pages might be held together by a spiraled wire. It makes it easier for you to browse the notebook without damaging the pages. Even your hair strands might have a curled shape. The curlier the hair, the drier it will be. It means it will get sebum from the scalp down on the strand slower, making it easier to maintain and clean. And before I spiral out of control, we're done here.
What if someone told you that life actually creates the universe? We're all used to the fact that the universe exists outside of us and was created with the Big Bang. But what if, in reality, it's us who create not just houses and cars, but the whole world? Sounds crazy, doesn't it? Well, let's discuss this fascinating theory. For centuries, there's been one way of thinking about the universe. It's brought us amazing discoveries and inventions that have changed our lives. But guess what? This model might be running out of steam. Scientists say that the universe was created from the Big Bang. Then, it was just a bunch of lifeless particles bouncing around until they started creating stars, then planets, and finally us. The current model is logical and well thought out, but the problem is it's still full of unexplained things. For example, it can't explain how life came to be in the first place. Sure, we can understand how life evolved and changed over time, but the real mystery is how it all began. When exactly did we humans become conscious? How do a bunch of molecules in a brain create our thoughts and experiences? That's a real head-scratcher. And even if we put the life and consciousness stuff aside, the current model falls short in explaining the basics of our universe. We know about the Big Bang, but where did this Big Bang come from? How can something come from nothing? It's a great puzzle, and we don't have the answer yet. Well, here comes Dr. Robert Lanza and his wild idea called Bioentrism. In 2007, he wrote a scientific article about how biology could join forces with quantum physics. It was so cool that 2 years later, Lanza and his friend Bob Berman wrote a book that expanded the ideas from the article. So what does Lanza actually believe? Well, he basically says that everything we perceive is within our minds. That everything, the whole universe, is all in your head. Of course, this idea isn't new at all, but Lanza tries to combine it with astrobiology and quantum physics to explain how exactly life creates the world instead of the other way around. His theory says that biology is the boss of the universe. He thinks that if scientists want to come up with a theory of everything, they need to start with biology as the foundation. According to him, our consciousness plays a big role in how we see the world. Space and time aren't real things, but more like how our animal brains understand stuff. Lanza also says biocentrism helps explain a lot of quantum paradoxes and puzzles. He even thinks that it might be a better way to bring all of physics together than Einstein's famous theory of relativity. So, let's take a look at 7 important ideas in biocentrism. The first one says that reality is connected to our consciousness, and what we see depends on us looking at it. We've got this idea that the universe exists on its own, even when we're not looking at it. If you have the kitchen in your house, the kitchen is always there, right? Well, not exactly. Our eyes capture tiny packets of light, but the real perception of colors, shapes, and movement happens in the back of our brains. Everything we see is because of light bouncing off objects and interacting with our brain. So without our brains, the kitchen would be just a bunch of random particles. In other words, when you're not in the kitchen, there's no real kitchen there. It's just a bunch of possibilities, like a shimmering swarm of matter and energy. It's pretty challenging to think about, isn't it? But to truly understand the universe, we need to go beyond our habitual ways of thinking. We need to embrace a viewpoint that's simpler, yet more demanding than what we're used to. We need to look at the world in a whole new way. Next, the second and third ideas say that particles behave differently when we watch them. Sounds creepy, right? But it's actually true. We observe this phenomenon many times in many experiments in quantum mechanics. Yes, particles actually change their behavior if they know they're being observed. It gets even crazier. Some particles can even instantly influence each other, no matter how far apart they are. It's like little atoms have a secret connection that defies space and time. This is why Lanza believes that bringing the observer into the picture, like us humans with our thoughts and perceptions, can help us understand things better. He thinks that the observer is the missing puzzle piece that can help us find a way to bring all the laws of the universe together. The fourth idea says that consciousness is super important, and without it, things get all fuzzy. Like we said, everything is intertwined, and there's no separate universe out there that's not connected to living things. Biocentrism suggests that the external world, everything we see, actually depends on us, the biological creatures. We're not just passive observers with clear windows to the world. In fact, without us interacting with the world, it's like the universe isn't really there. Just like the kitchen disappears when we're not there, and the universe is all about how we experience it. Reality is a dance between us and the world. It's a whole new way of understanding everything. The fifth idea points out that the universe seems to be just right for life to exist. There are over 200 things in the universe that have to be just right for life and consciousness to exist. If the Big Bang had been even slightly stronger, everything would have zoomed by too quickly for galaxies and life to form. That means no us. And if the forces of nature, like gravity, and the strong nuclear force were tweaked even a little, atoms wouldn't hold together, stars wouldn't ignite, and we would be left with plain vanilla hydrogen everywhere. Of course, there's many theories on why this could be the case. We could also look at this phenomenon the other way. It's not that things were made this way specifically for us, but our existence is a result of things being this way. We're just the result of particle movements and certain conditions. Biocentrism, however, has a more fun way to look at it. Life creates the universe. The universe and its parameters are a reflection of the logic of our existence as living beings. And finally, the sixth and seventh ideas say that space and time are not things, but tools our animal brains use. Think about it for a moment. Does time really exist? Well, the reality of time is a bit shaky. According to biocentrism, time is simply our way of making sense of the world, a tool for understanding. It's not some external force. Our mind weaves together snapshots of information, creating the illusion of time. So when we perceive time passing, it's just our human perception at work. And what about space? In our daily lives, we think of space as a vast container without walls. But in reality, space is full, not empty. There's no fixed measure of distance anywhere. You believe that you're far away from your kitchen, but everything around us is just a bunch of atoms almost without any empty space in it. Well, there you have the basic ideas of biocentrism. In his books, Lanza explores these ideas very deeply and tries to answer philosophical questions, like if death is just an illusion, or if plants are aware of things. They even talk about whether machines can ever become conscious. Some people aren't sure if this theory can be proven right or wrong. Unfortunately, there's no way for us to test it right now, but Lanza hopes that in the future we can do cool experiments, like huge quantum superposition thingies, or either prove or disprove his theory. Until then, it's more like a cool idea than anything. No matter which theory you prefer, one thing is clear. We live in a truly peculiar world. So let's keep exploring it and discover new, amazing things.
Now, I don't want to spook you, but there's a chance that our entire Milky Way galaxy is located in the so-called space void. It's a region where there's relatively little matter compared to other corners of the known universe, and it's much less dense than it is elsewhere in the universe. In other words, we might exist in an air bubble in a cake. If that's true, it would mean that we're even lonelier than we thought. In our universe, all the galaxies are constantly moving away from each other. In order to understand how far they move away, scientists use something called the Hubble-Lemaitre constant. It's like a speedometer, but for galaxies. However, there's a cosmic mystery called the Hubble tension. It's challenging what we know about the universe's expansion. Scientists used to consider the Hubble-Lemaitre constant a reliable guide, but our recent observations question this reliability. The speeds we see in real life don't match up with the distances we calculated and expected. They aren't sure why these measurements don't add up. Researchers followed the moves of supernovas and saw that the universe seems to expand faster around us than it does overall, as if it's actively avoiding us specifically. After considering this, they began to assume that we might all live in a cosmic void. Cosmic voids are vast, empty spaces between galaxies, kind of like between my ears. They make our entire world look like a big sponge. Now, let's go back to the beginning, just a fraction of a second after the Big Bang. Right after the beginning of everything, the universe was a hot, compressed plasma. It only had very tiny variations in density, called quantum fluctuations. After the Big Bang, the universe began to expand. Those quantum fluctuations grew together with it, creating regions of varying matter density. Because of that, the universe didn't expand everywhere uniformly. Instead, little claps of matter began to gather together over a long period of time, creating massive structures, galaxies. Galaxies are arranged in huge walls and filaments, with enormous gaps in between. And these gaps are voids, also known as dark space. Now, these voids aren't truly empty. In fact, they actually hold more than 15% of the amount of matter found on average throughout the entire universe. They still contain gas, dust, dark matter, and even stars and galaxies. However, they have less density than regions with galaxies, about a tenth of the average matter density, which is why we consider them nearly empty. Usually, they'll have a diameter ranging from about 30 to 300 million light-years. That is an enormous distance, even on a space scale. For comparison, most planets and nebulas we've found so far have a distance of hundreds and rarely thousands of light-years away from us. In the case of voids, if you were in the middle of one, it would just look like seemingly eternal darkness. The closest stars would be so far away that they would be almost invisible to you. Some of them are especially large. They're known as supervoids. The largest known one was creatively named Giant Void. It's so big, it's impossible for us to even imagine. 1.5 billion light-years away, with a diameter of 1 to 1.3 billion light-years. Yeah, it's basically a big dark vacuum. But even this giant vacuum isn't entirely empty. The Giant Void houses 17 separate galaxy clusters within its expanse. However, it might not be the biggest emptiness in our universe. There's this thing called the CMB cold spot. It's this unusually large and chilly area of our universe that we saw through the microwaves. It really stood out on the map of our universe with its unexpectedly low temperatures, and scientists have spent many years trying to figure out what the thing is. In 2015, scientists proposed that this place might be a supervoid, and probably the largest one ever. Being even more original with this one, they called it the Great Void. If it's true, this place would be an emptiness of about 1.8 billion light-years in diameter, about 1,000 times larger than typical voids. Not everyone thinks that's possible, so scientists keep arguing over this one. There's another interesting theory going about this place. One researcher suggested that this place might have been a trace on our collision with a parallel world. It's a pretty bold hypothesis, but unfortunately, there's no way for us to confirm or deny it with our current technologies. In any case, as the universe expands, these voids will grow, and the walls connecting galaxy clusters will stretch and break. Eventually, the voids will merge, leaving gravitationally bound galaxy clusters as islands in the expanding emptiness. In other words, sooner or later, the great emptiness will consume everything in our world. So, it turns out we might be a rare occasion in a supervoid, one of the 15% of matter. This would explain why we're surrounded by relatively few galaxies. This discovery, if true, challenges the standard model of cosmology, which we created with Albert Einstein's help. It would mean that gravity in general behaves differently than what we expected. According to the standard model, such a significant underdensity shouldn't exist. Because of that, scientists will have to explore and consider this idea thoroughly. It might just challenge our very basic understanding of physics. The scientists call this the local hole. The discovery of the local hole may hold clues to explaining the Fermi paradox. Maybe in this specific part of the universe, where we hang out, the chance of intelligent life developing anywhere nearby is very low. Perhaps all of the sentient beings hang out somewhere beyond our supervoid. But that doesn't mean we should lose hope, or that life anywhere nearby is impossible. In fact, life in the universe might be much more common than we previously thought. We know that the inner planets, like Mercury and Venus, are inhospitable due to extreme conditions. However, Venus looks interesting because even though it's a crazy toxic planet, scientists believe that it was very Earth-like in the past. It could have even hosted life. Unfortunately, it was too close to the Sun and all the nice conditions evaporated over time. But there's a possibility of microbial life surviving in its high-altitude clouds. Mars, a cold desert, also might have been a friendlier place in the past with rivers and lakes. Though now it lacks a protective atmosphere, ancient life might have existed there. In that case, it would leave potential fossils and underground microbes could still survive. We've discovered some signs of them, but are still debating whether this stuff was truly organic or not. The gas giants, like Jupiter and Saturn, and ice giants are not ideal for life, but their moons offer hope. Europa has an ocean beneath its icy surface, making it a potential hotspot. Enceladus releases water into space, carrying complex molecules that hint at interesting possibilities. And Titan is especially unique. It has liquid bodies on its surface, rivers and lakes of hydrocarbons. While its frigid temperatures aren't great for life, scientists ponder if it might host life with a different kind of chemistry. However, it will take us decades to check all these celestial bodies and study them properly. We haven't sent anything so far since the times of Voyager 2. But if we're lucky, we might explore our solar system during the 21st century. In any case, there's a lot of potential for life even in our solar system alone, not even mentioning all the planets and galaxies we found nearby. Our estimates suggest that the observable universe, the one we can see, might host around 5.3 trillion habitable worlds. One of the most likely candidates so far is Kepler 186f. It's a potential Earth-like planet, just 10% larger than Earth. This planet orbits a red dwarf star, which is a star a bit dimmer, colder, but more long-living than our Sun. And it's only about 490 light-years away, which may sound like a lot, but remember what distances we've discussed with supervoids. So even if we really are in a supervoid, we're still lucky to have many galaxies and planets around. And if one day we'll find a way to travel through the universe, leaving the local hole probably wouldn't be a problem.
We fly away from Earth to look at it from a distance. It glows like a holiday tree. Big cities look like yellow spots at night, and during the day we see strange structures, like a palm tree-shaped island in the UAE, or a dark band that runs all the way through China, the Great Wall. These are traces of human existence. Now let's point our telescope at other planets. Mars? It's just an empty, endless desert. Venus? Only rocks and volcanoes. Even if we look into distant space, all the planets out there are deserted and lifeless. Not a single trace of an extraterrestrial civilization. Many people are convinced that life on Earth isn't unique at all. Here's our galaxy. There are billions of sun-like stars. And here is the entire observable universe with billions of such galaxies. There's an almost infinite number of stars, and near each of them, there may be habitable worlds. But we may not have found life on other planets because it hides from us under the surface. For example, there's Europa, a satellite of Jupiter, slightly smaller than our moon. Its structure resembles a soft-boiled egg. Its surface is a hard crust of ice, but if you take a big enough drill, you can get to the liquid yolk, an ocean of water. Jupiter and its satellites are very far from the Sun, so it's quite cold there, about 270 degrees below zero. So liquid water instantly turns to ice. But Jupiter has a strong gravitational force that causes a lot of friction inside Europa, and its core heats up. The heat melts the ice, and we have a watery ocean under the surface. Water is the foundation of all life, so there could be simple bacteria in that ocean. And who knows, maybe there are other life forms out there. For example, weirdly shaped fish. Because of the weak gravity, their bodies are built differently, or something like whales feeding on plankton. In 2009, scientists found a planet that is completely covered by an ocean, GJ 1214. It's about 40 light-years from Earth, and about 75% of its mass is water. Still, the temperatures on this planet are so high that water evaporates and takes the form of superliquid water. There's so much steam that it feels as thick as water itself. No life could exist in such conditions. But scientists have recently found at least 24 planets better than Earth and called them superhabitable. These planets orbit distant stars in their habitable zone. It's the sweet spot at a perfect distance from the star. In our solar system, Venus, Earth, and Mars are in this zone. A superhabitable planet must be 10% larger than Earth and have stronger gravity. That way, it can have a denser atmosphere. A temperature 8 degrees higher than on Earth would make the planet more humid. This would encourage a variety of living organisms there. These planets may be great for life, but it's hard to tell if there is life there already. The main marker that would confirm the existence of an advanced civilization there might be radio waves. Imagine a habitable planet similar to Earth. In the process of evolution, intelligent beings appeared there, like humans. They're much taller because of low gravity, and their eyes are adapted to the light from another star, much brighter than the sun. Sooner or later, this civilization will have to use radio waves to communicate with each other. We can think of these waves as loud sound from speakers. Here's Earth. We're now actively using radio waves, and the noise coming from our planet is pretty serious. If a neighboring planet had radio telescopes, big dishes that catch these waves, they would realize that life is blooming here. There are many radio telescopes on Earth that are pointed into distant space, waiting for a signal from aliens. But we haven't received anything yet. Still, that doesn't mean there isn't a planet somewhere in the universe that emits radio waves. It's all about distance. We're jumping 200 light-years to another star. Suppose there's a planet X where life exists. The civilization here is advanced enough to use radio waves, so they release the first wave into space. Our radio telescopes won't be able to pick it up until 200 years later. This also works the other way around. Radio communication on Earth has only existed since 1895. Our radio signal won't reach Planet X until 2095, and only then the aliens will hear our voice. But this radio noise doesn't stay for long. Every year, our technology improves, and our radio noise decreases. We're beginning to use mobile communication, cable TV, and fiber optics. This all reduces the volume of our planet in the radio spectrum, and soon it will simply become invisible to other planets. The same thing is happening on the other side. So, the radio waves coming from civilizations are a brief blip on the cosmic scale, and we can't accept radio silence as proof that extraterrestrial life doesn't exist. A giant telescope, which could take a direct photo of a possibly inhabited planet, would change the situation. We zoom in on the photo, and there it is! We see alien cities with tall buildings and lots of antennas. But now, we can't look that far away. We can take pictures of Mars and its satellites, and even their quality misleads us. For example, Cydonia. It looks just like a human face on Mars. We thought there used to be an ancient civilization there that made some sort of sculpture or memorial. More extravagant theories said it was the remains of a giant human, and there's a whole body of it under the sands of Mars. But in fact, it was just a hill. Strong winds blew out some hollows there, and when there was a shadow in those hollows, we took them for human eyes and a mouth. Or a monolith on Mars's satellite Phobos. We found a smooth rock there that was almost as tall as the pyramid of Cheops. The news has spawned many theories about the civilization that built it, but it turned out to be no more than a rock. The infinite number of stars and worlds around them almost guarantees the existence of other civilizations, so why wouldn't they come to Earth, right? We think that life throughout the universe develops in similar scenarios. The emergence of simple life forms, followed by evolution, and growth of a technologically advanced civilization. But, just like on Earth, cataclysms happen there too, causing mass extinctions. Meteorites, for example. Perhaps there was a civilization out there ready to go into outer space, but a huge meteorite, like the one that wiped the dinosaurs off the Earth's surface, made that civilization disappear, and life on that planet began a new cycle from scratch. In addition, the more advanced the civilization, the greater the risk of its self-destruction. Scientists might conduct experiments in machines like the Large Hadron Collider and accidentally create a black hole there. It would begin to swallow everything around it and grow in size. Soon, all the super-developed cities of this civilization and the entire planet would simply disappear. Another possibility for super-advanced civilizations is to travel through wormholes. Those are tunnels in space-time between universes. Aliens might travel through them and lose interest in going back. But it's also possible that life on Earth is unique. That's because our planet was formed thanks to a number of incredible coincidences. The first is the location of our solar system in the galaxy. In the Milky Way, there are constant fireworks of exploding supernovae. The radiation from these explosions destroys everything around it at great distances. Our solar system is right in the sweet spot of the galactic orbit where we're safe from such explosions. Another factor is the moon. One theory of the formation of the moon says that about 4.5 billion years ago, a meteorite the size of Mars crashed into us. If the impact had been straight, the Earth would have just broken apart. And if that meteorite had only scratched the Earth, the pieces would have just flown away. But the collision occurred precisely so that part of the meteorite remained in Earth's orbit and formed the moon. Then, the moon stabilized the Earth's rotation and heated our core with gravity. Only then, our planet developed a magnetic field, which protects us from the solar wind. Other scientists believe that life outside Earth may be biochemically different. Carbon and water are the basis of our bodies, but carbon could be replaced with silicon or phosphorus, and water could be replaced with ammonia or methane. These atoms could form molecules of different shapes and perhaps assemble into a living organism. Life based on such elements would be unlike anything seen on Earth.
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And, according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
Now, when we say the word universe, we're already picturing this vast space filled with stars, planets, and comets. Truth is, most of us find it hard to actually picture how large the universe is. Well, try to think of space as the biggest playground you've ever seen. Right now, our space playground goes on for 46 billion light-years. It wasn't always like that. On that note, you've surely heard of the Big Bang Theory. Let's try to unpack it. Imagine the whole wide universe, every star, planet, down to the smallest particle, squished into a tiny superhot ball the size of, let's say, an apple. From that point on, we've got a pretty neat roadmap of how things unfolded in the cosmos. Dive even deeper into the universe's past, and things start to get a bit blurry. The energies and temperatures rise, and suddenly our rulebook of physics doesn't make sense anymore. When we reach these early times, gravity, that force that keeps our feet on the ground, starts acting all mysterious. This is where we bump into the great puzzle of our time, quantum gravity. And here's the honest truth, we've still got some homework to do on that one. What made the Big Bang go pop in the first place? Well, it's kind of like asking what happened before the first page of a book. There's no page 0, or at least that's the answer that quantum physics provides. It tells us that there are events in the universe that just, happen. It's not because we're not looking where we should, it's just how the universe works. Or at least, that's our current understanding of it. Right after the blast, everything was just a bubbly mix of gas, like this soda can that just got opened. This gas, which was mainly helium and hydrogen, began to stretch out and cool down. If we could time travel to those times, we'd see a younger, hotter, and cozier universe. Cool telescopes like the Hubble and James Webb let us peek into those ancient times. And what we see is fascinating. Earlier galaxies were like the cute photos of the universe when it was younger. Tinier, less heavy, and not as evolved as they are now. Over billions of years, the universe stretched out like a soap bubble. Imagine countless shiny marbles inside it, representing stars and galaxies. As the bubble grew bigger, the marbles spread out. Today, inside our bubble, we have trillions of galaxies. For every single galaxy we can spot, there are tons more we haven't seen yet. Some are too tiny, others are too far away. We still can't see them even if we use the fanciest telescopes available. Just to paint you a better picture, know that today our very own Milky Way is home to around 400 billion stars, similar to the Sun. It was a lot different in the past, though. Our galaxy began its journey like a little bundle of stuff, just a tad denser than most things in space. A lot of it was actually made of dark matter. Our closest star friend, named Proxima Centauri, is 4.2 light-years away. To put that in earthly terms, that's like taking a road trip around our planet millions of times. It's also about the same age as the Sun. If we could have looked at the exact spot about 5 billion years ago, it wouldn't have been there at all. Many stars live together in groups, kind of like families. However, most are solo adventurers, experiencing the vastness on their own. When you zoom out from our Milky Way, and peek into the larger universe, it's more, well, empty, like a vast piece of countryside between big cities. In our cosmic area, we've got some cool neighbors. The Andromeda Galaxy, for instance, is just a stroll away, in cosmic terms, at 2.5 million light-years. And there are lots of smaller galaxies too, like the Triangulum Galaxy and the Large Magellanic Cloud. Our local hangout spot, which includes all these galaxies, spans about 3 million light-years. As we explore further, galaxies seem to gather in clusters, like suburbs. Connecting these clusters are threads of galaxies, creating a giant web in the universe. Galaxies are clustered this way because, just like magnets, they love to pull stuff towards them. If we could turn back time, we'd see a different picture. That's because throughout history, the popular galaxies with lots of stuff became even bigger, while the less popular ones gave their items away. From Earth, we can only see objects that are 46 billion light-years away at the most. If we put all this space into a giant box, its volume would be unimaginably huge. The main reason our universe is such a grand spectacle today is that it's been growing nonstop. Every year, its size increases a little more. In fact, the universe is expanding faster than the speed of light. Sure, we can't feel it down here on Earth, but there are clear signs in the universe that it's happening. We're still not sure why the universe behaves like that, but scientists are working hard to figure out this mysterious expansion. Our understanding of the universe has changed a lot over the years, too. Back in the day, when our world had more trees than buildings, people from all corners of the Earth would gaze up at a twinkling sky above. For many, the sky was their roadmap, alarm clock, and spiritual connection point. Now, imagine not having a smartphone or a compass and still being able to find your way home or knowing when to plant your crops. That's because our ancestors had the sky. They knew when it was time to take care of plants, navigate ships, or celebrate special occasions, all by watching the stars and planets. Long ago, people in Babylon spotted some stars that behaved a little weirdly. These stars seemed to have a mind of their own. Obviously, we know now that they weren't stars at all. They were planets, like Venus and Mars, that sometimes wink at us down here. There was also a time when we believed the Earth was flat. Well, at least some people did, before Greeks in the 6th century BCE figured out that it's round. They even managed to guess its size by watching shadows in different places. They were pretty close with their estimations, especially if you take into consideration their limited tools. Now, speaking of our planet, there was also a time when humankind believed the Earth to be the center of the universe. We also believed everything else was just spinning around it. That was until a man named Copernicus did a bit of research and figured out it was actually the sun coordinating all the movement in our system. And soon after, other thinkers and stargazers joined in on the fun, changing how we perceive the universe using new tools. Speaking of tools, thanks to a telescope, Galileo found out that Jupiter had massive moons tagging along. We call them the Galilean moons today in his honor. But the universe kept tossing surprises our way. Some people started cataloging stars, clusters, and nebula, while others found mysterious rays that our eyes can't see. And just when we thought we had it all figured out, Edwin Hubble, not the telescope but the man behind the name, discovered something amazing too. He realized that other galaxies are in fact moving further away from us. These days, we're looking at the universe in a different way. We know how the timeline works now. We know that our time here on Earth is limited. No wonder astronomers are eagerly scouting through the vastness of space, looking for planets similar to ours. There is no other planet that can safely accommodate us in our solar system. But we can use our neighboring planets and satellites for scientific purposes. Take Mars, for instance. In the following decades, NASA is planning to send all sorts of devices and even people up there. If the experiment proves to be successful, we might end up living there for a while, or at least use it as a pit stop for our next exciting destination.
Look at the sky. You can choose any direction, and still, the limits of what you can see extend to astronomical distances. The most ancient light we can observe was emitted a mind-boggling 13.8 billion years ago. This date corresponds to the Big Bang itself. That's why the following fact may sound so confusing. When, after traveling through the expanding universe, light arrives on Earth, it provides us with information about objects currently located around 46.1 billion light-years away. It's only possible because of the expanding fabric of space. That's how the most ancient light we can see corresponds to distances much greater than 13.8 billion light-years. With time, we'll be able to see even farther away since light that's still on its way will finally reach us. And still, at any given time, there will be a limit to how far we can see. That's the limit to the observable universe. It also means that at any point in the past, the universe had a finite size too, and it was smaller than today, depending on how much time had passed since the Big Bang. Okay, but what would we see if we went all the way back to the beginning? To the moment of the Big Bang? Surprisingly, it wouldn't be a singularity, with the universe having infinite density and temperature at a barely perceptible size. No, there would be a limit, and it would be the smallest size the universe could have had. Let's find out together why such a limit must exist and how tiny the early universe could actually be. If you want to know anything about what our universe will do in the future or did in the past, you need to figure out the rules and laws it follows. And all of them are set forth by the theory of general relativity, which claims that what we perceive as the force of gravity comes from the curvature of space and time. One more thing to remember is that the universe is both isotropic, having the same properties in all directions we look, and homogeneous, having the same properties in all places we could go to. But if the universe has the same properties in all places and all directions, it means that it must either expand or contract. Let's say you know its expansion rate at the moment. Then you can determine the size of the observable universe at any moment of the past or future, its expansion rate at any point in the past or future, and how energetically important each component of the universe was or will be in the past or future. And by these components, we mean radiation, normal matter, dark matter, neutrinos, dark energy, and so on. To figure out what our universe did in the past, or will do in the future, we need to understand how every component evolves with time and when and under what circumstances these components transform into one another. According to the theory of cosmic inflation, the universe was once filled with large amounts of energy. It was similar to dark energy, but much greater in magnitude. It made the universe expand faster and faster. As a result, the universe was getting colder and emptier. And then, after growing this way for a very long, possibly infinite amount of time, most of this energy got converted into matter and radiation, which triggered the Big Bang. Now, about the size of the universe. Today, 13.8 billion years after the Big Bang, the universe is 46.1 billion light-years across. When matter started to dominate radiation, which happened when the universe was around 10,000 years old, the size of the universe was about 10 million light-years. When the universe was 3 years old, it was roughly the size of the Milky Way galaxy. When the universe was just 1 year old, it was both smaller than our home galaxy and unbelievably hot enough to start nuclear fusion. And when the universe was a mere 1 second old, it was too hot for nuclear fusion to occur. Its radius was just 10 light-years, which is still enough to enclose 9 nearest star systems we know about. And if we somehow managed to observe the universe when it was just a trillionth of a second old, we'd see that it was the size of Earth's orbit around the sun.
We've never sneaked a peek beyond the edge of the observable universe. What lies there? If we managed to get there, would we find another universe? What if the universe we live in is just one of billions of trillions of other universes? I'm talking about the concept of a multiverse now. Look, there's this idea of parallel universes. Let's take one of them. It looks exactly the same as our universe, and still, some details differ. Maybe instead of becoming a doctor, you chose to start a music band there. Maybe one infamous asteroid changed its trajectory, and dinos are still roaming Earth in that universe. But the multiverse theory takes it all one step further. Those who believe in it state that there might be countless realities. According to this theory, We live in a bubble that is just one of many other bubbles, which I guess looks like bath foam. These bubbles constantly bob up and vanish. Multiverses are described by a few scientific theories which mention various possible scenarios, from separate universes that keep springing into existence all the time, to regions of space that are in different planes than our home universe. But there's one thing these theories agree upon. All of them suggest that the space and time we observe is not the only reality. You see, it's impossible to explain all the quirks of our universe if it's the only one to exist. So it's either inventing newer theories that can throw light on certain properties of our universe, or accepting the fact that we're living in just one of many, many universes, all of which are different. One of the most widely known multiverse theories is called inflationary cosmology. This is the idea that right after the Big Bang, the universe expanded rapidly and exponentially. Indeed, cosmic inflation does explain lots of the properties of the universe we observe. For example, the distribution of galaxies. When this theory was suggested for the first time, it was perceived as a piece of science fiction. But it can indeed explain tons of interesting features of the world we live in. So with time, people started taking it seriously. Now, the theory states that inflation might happen again and again, maybe even infinitely. And this could create constellations of bubble universes. Of course, none of these bubbles will have the same properties as ours. There may easily be places where physics as we know it doesn't exist. But even though some of these universes might look like ours, they all lie beyond the realm we can observe directly. Another theory, called the many worlds interpretation, claims that there might be multiple branching timelines, or alternative realities. And in each of those realities, our decisions play out differently, which also means very different outcomes. At the same time, the only reality you can perceive is the one where you live. If it's true, then the question is, where are all those other universes? Well, they most likely all overlap in dimensions we absolutely can't access. And at the moment, it's not possible to travel between universes. But who knows? Maybe a few thousand years later, people will not only find a way to prove that parallel universes exist, but also invent a method to hop from one of them to another. Unfortunately, so far, there's no solid evidence that multiverses exist. All the proof we've got today is purely theoretical. Some experts even argue that it could be an unbelievable cosmic coincidence that the Big Bang created such a perfectly balanced universe as ours. Or, if parallel universes do exist, we might have just inhabited the one that had all the right conditions for our survival. It's still unclear whether the multiverse theory is even testable. Perhaps we just haven't thought of the right tests yet. Now, I've got one scary thought for you to consider. What if, at one point, you stopped existing in your home universe, the one you were born into? What if your consciousness was transported to a parallel universe, where you're now watching this video? Think of this.
So, dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see it or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the law of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going on for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future circular collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor. Wink, wink. It's a crazy massive region in space, about 10 million billion times the mass of our Sun, with a super powerful gravitational pull. Scientists think it might be a supercluster of galaxies, but they're not sure. The problem is, we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 370 miles per hour. Now, just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled toward this region, even though, since the universe is expanding, they should be moving away from each other. What's even weirder is that this Great Attractor might itself be moving towards something even bigger, the shapely supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 330 feet to about 0.6 miles long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed by the Sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird-looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua ever since. But after a while, it turned out it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Hey, stay tuned. Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that with trillions of planets out there, there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all of its astrophysical and geological conditions, should line up perfectly for complex life to develop. So just think about it. Being in the right zone of the galaxy, on a good distance around a stable star, a rocky planet with water and the right temperature, emergence of molecules, monkeys deciding to walk, and so on. This would explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter. Dark matter? And even if they do exist, we could be incredibly far away from each other. That would make communication or contact with other intelligent species very unlikely. Now, there's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe, although he assumed it's not because our planet was the result of tons of unique conditions, but because there must be some sort of filter that reduces the chance of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it or somehow ahead in the future, which means we might go extinct like many other species before us. Well, maybe in the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up, potential catastrophes, resource exhaustion, or other challenges. Now, there's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. You see, in space you often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system, which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size. But the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kind of like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they've failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many times the current age of the universe for it to completely evaporate. We found a water cloud in space around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the Sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that the water isn't young at all and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that. Now in space, inky darkness between blinding points of light does a great job. It hides black holes, gaping, hungry, and scary. Their blackness makes it really difficult for astronomers to find detailed information about these space monsters. When a powerful and massive star reaches the end of its life, it can't just fade into nothingness. One of the most likely scenarios, the star will run out of its nuclear fuel. Then, in a blazing flash of light, it'll collapse under its own gravity. If the star was large enough, it'll turn into a black hole. There's a hypothetical type of black hole called primordial. Scientists have never gotten any real proof of their existence. These holes are insanely old and quite tiny, by black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but the bigger ones can still be scattered out there in space. But how did primordial black holes appear in the first place? In the very beginning, space wasn't the same. In some regions, it was hotter, in others, cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though? These holes might be so small exactly because they popped up right after the Big Bang. The longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our Sun's and that of a jelly bean. Now you get it. There was a theory that primordial black holes could actually be dark matter. This matter is believed to make up around 80% of the mass of the observable universe. Astronomers can't see this bizarre ingredient directly since it doesn't emit light or any kind of energy. The idea remained unpopular for decades, but recently, scientists have realized there are many more black holes in the universe than they used to think, and it means the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching. Some scientists argue that dark matter can't be tons of multi-sized primordial black holes. They would collide far too often for this to work out. Others object that black holes might exist in twos, and then a third one can always approach the pair and replace one of the initial holes. After all, our universe is swarming with black holes, and there's no lack of them. This process would repeat again and again, meaning there would be almost no merges or collisions. Primordial black holes might stay in clusters the size of the distance between our Sun and the nearest star. Each of these clusters can be home to thousands of black holes, all crammed together. A 30 solar mass monster of a black hole might sit at the center, with more common stellar ones occupying the rest of the space. Such clusters can be everywhere astronomers think dark matter is. But so far, this is still only an exciting theory, and some scientists don't support it yet. More data is needed. Now, black holes sometimes behave like massive galactic volcanoes. From time to time, they flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Whoa. Recently, astronomers have found out that one of the most massive stars in the neighborhood might just have vanished. The star used to hover in space 75 million light-years away from Earth. It's usually too far away for scientists to clearly see individual stars, unless they're really massive, like the one we're talking about. It was gigantic and shining 2.5 million times brighter than our Sun. For the last time, astronomers saw the star's light in 2011, but when they decided to examine it more closely several years later, they couldn't find it. Such huge stars usually go out in an extremely bright supernova, but nothing here, which puzzled the scientists to no end. There's a theory it collapsed into a black hole, and it happened without triggering a supernova first. It does occur among stars nearing the end of their lives, but very rarely. KB 141b is a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate into clouds, condense, and get back to the surface as rain. But instead of water, this all happens with rock. The surface of the exoplanet is covered with lava seas tens of miles deep. The temperature on K2-141b reaches 5,000 degrees during the day. That's hot enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor to the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Well, looks like we're gonna need a bigger bumbershoot. A star in the galaxy GSN 069 might turn into a planet the size of Jupiter in the next trillion years or so, all thanks to the star's regular encounters with a black hole. First, astronomers noticed bizarre X-ray bursts. Those were super bright and went off every 9 hours. After examining this phenomenon, the researchers realized it was a star getting flung in a unique orbit around a black hole, and the flashes they saw were the material being slurped off the star's surface. It happened every time the star darted past its greedy host. Over millions of years, the black hole has already transformed the red giant into a white dwarf, and the process isn't going to stop anytime soon. Astronomers have recently discovered some traces of phosphine in Venus's atmosphere. On Earth, this colorless and flammable gas is often found near microbes. That's why a new theory claims there might be life on Venus. But if there is, it could only appear high in the clouds, because no living organism would be able to survive the planet's extreme environment. Its surface is incredibly dry, with no liquid water, and the pressure 90 times greater than that on Earth's surface. The temperatures there reach almost 900 degrees, hot enough to melt certain metals. So that's a no? Methane, a gas that's usually produced by living things, was found on Mars in 2013. European Space Agency's Mars Express spacecraft detected it in Gale Crater near the Martian equator. This discovery might one day answer the question if there's life on Mars. Asteroid 2019 OK scared scientists by sneaking up on our planet in July of 2019. This rather large rock, up to 400 feet across, appeared seemingly out of nowhere. It traveled uncomfortably close to the Earth, a mere 45,000 miles away. That's less than 1/5 of the distance to the Moon. The Sun's outer layer is way hotter than its surface. The temperatures vary from 10,000 degrees close to the surface and a mind-boggling 1 million degrees in the corona. That's the Sun's outermost layer. The reason for this phenomenon might be nanoflares. Those are regular, powerful bursts of heat from the star. Another theory blames the layer that lies just beneath the Sun's surface. It seems to generate a weak magnetic field. That's why, when the energy from this layer leaves the Sun, it heats the corona through a mesh of magnetic branches and roots. The Moon might still be shrinking. Our planet's natural satellite has become 150 feet skinnier than it used to be several hundred million years ago. If its insides keep cooling, it might explain the quakes shaking the Moon's surface. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than the Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses are. Maybe after midnight they're gonna let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Oh, by the way, our Moon also has some sort of atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. Or, really thin. Are we really by ourselves in the universe? It's a daunting question that's been haunting us for centuries. No wonder scientists have tried to come up with all sorts of ideas as to why. One of the strangest theories concerning our lack of contact with other life forms is named the dark forest theory. Let's start small, well, sort of. We'll focus on our Milky Way for now to better understand this theory. Our cosmic neighborhood is a galactic wonderland, sprinkled with 200 billion twinkling stars and maybe around 100 billion planets. So let's get hypothetical for a moment and say a tiny part of those habitats hosts life. Further, out of those life-bearing planets, a few might have evolved into intelligent beings. Given that, you'd think we'd be knee-deep in weird-looking neighbors, some of whom might be actively trying to find us or might just be out there, waiting to be discovered. Now, let's put a little science into this science fiction scenario. We have something called the Drake equation, which is a kind of universal roll call that estimates how many smart civilizations could pop up in our galaxy. You can think of this equation as the super smart roadmap. By playing around with a few important factors, the equation hints that there should be around 20 civilizations just in our galactic backyard. So why haven't we stumbled upon any yet? This theory isn't an easy task. It's a mixed bag of multiple variables, like the average number of planets per solar system that could potentially host life, or the rate at which stars suitable for intelligent life are formed. A tricky part here is that astronomers have yet to solidify the exact values of these variables, which means our calculations are just approximations for now. But back to the Milky Way, shall we? Feed in our hypothetical assumptions, crunch the numbers, and you get at least 20 civilizations. Yet somehow, our cosmic switchboard remains weirdly silent. How come? This radio silence has its own name too, the Fermi paradox, named after the guy who first thought, "Hey, where is everybody?" over 50 years ago. Since then, we've had a lot of different theories trying to solve this mystery, all tinkering with different aspects of the Drake equation. Some folks think the appearance of life is a rare event. Others think that getting from bacteria to advanced beings is the tricky part. Yet, some reckon that civilizations might either wipe themselves out after a short lifespan or never even get to invent something they could communicate with. But there's one theory that tops all others in its creepiness: the dark forest theory. According to it, the universe is a huge cosmic version of a haunted forest. And other types of creatures are out there, playing a game of hide and seek. They're intentionally keeping silent. Why? Well, the dark forest theory was best explained in a sci-fi novel, and the rationale goes something like this. For starters, every life form wants to stay alive. I'll buy that. If we go with that assumption, it's impossible to be sure whether other life forms might harm you if they get the chance. So, the safest bet is to take them out before they find the right time to do the same to you. Frankly speaking, it's the universe's version of the survival of the fittest. In this scenario, making contact with others becomes the most dangerous game, as it could lead to your location being traced and you being wiped out. How human. This results in everyone keeping quiet, a kind of universal shush, where every civilization tries to hide in utter cosmic silence. But hey, is this just an idea good for a thrilling novel, or does it have some real-world implications? Well, the theory was suggested by scientist David Brin as a possible explanation for the lack of radio evidence for non-Earth-like life. He went as far as imagining it would be robots that would do the dirty work of wiping out civilizations. But how realistic is this theory anyway? Well, it doesn't require us to assume a lot of stuff about the behavior of all foreign civilizations. Just one advanced race behaving this way could explain our observed reality. And it might explain why we've not picked up any advanced radio chatter despite a century of eavesdropping. It's possible that other creatures like us are too terrified of being noticed and have gone radio silent on purpose. But, and it's a big but, like mine, it does base itself on the notion that other species share our level of risk aversion and logic, or that there's a rogue civilization out there, picking off anyone they perceive as a threat. And that's a pretty significant assumption. If that doesn't sound creepy, this next piece of information certainly will. For about a century now, we've been shouting our existence into the cosmos. If this theory proves to be correct, every other civilization within 100 light-years of us might be getting our signals and knowing exactly where we are. And if we have reasons to hide from them, as suggested by some like Stephen Hawking, we might already be in trouble. But what if this theory isn't true? What if, sooner than we'd like to imagine, weird galactic creatures will indeed try to reach us? The truth is, most of us wouldn't even know what to do. Hey, let's not get over ourselves. In fact, some scientists are tackling this issue head-on. For the first time since the 1980s, specialists are trying to cook up a how-to guide for when we inevitably bump into cosmic neighbors. For instance, some researchers believe we've got to do more than just worry about how these life forms could shake up our world. If they send any type of radio signals down here, we've got to think about our reply. What are we going to say? Hey, we're humans. Nice to meet you. Absolutely not. We've got to do better than that. See, the only plan we've had till now came from a rough blueprint dating from 1989. This guide is a bit wishy-washy on what to do when the entire world gets the outer worldly text. Mostly it says, hey, let's share the news with everyone. But then what? If we confirm it's legit, officials will need to ask the United Nations for advice. But hey, does the United Nations even have a plan? Maybe, who knows? We've been doing loads of space exploring lately. Some say we've stumbled upon water on Mars. Others are sure we've spotted some planets that could be twins to Earth. So, the idea of finding life elsewhere isn't that far-fetched. But even after 100 years of trying to chat with cosmic beings, it's still a one-sided conversation. This new protocol isn't just about chatting up outsiders. It's also going to act as our cosmic voicemail, checking messages from outer space. It aims not just to decode the external lingo. It's also planning to figure out what these messages could mean for us. The plan is also to draft reports about how different policies could impact us and set up guidelines on how to respond to these space texts. So, will we ever get a message from our cosmic mates? Only time will tell. But what we do know is that we just can't wing it. We can't be caught off guard and start a planet-wide frenzy when we get that otherworldly WhatsApp. We gotta have a plan, and we gotta have it ready for when we're face-to-face with the real deal. I mean, we've come across a lot of potential such sightings, but none of them proved to be genuine. On that note, U.S. authorities checked over 100 cases of weird stuff going on in the skies. I'll spare you the details, but not one green creature was ever found. More like drones and similar stuff floating around. So, as we stand on the cusp of this potentially game-changing event, we must strive to be prepared. Whether our intergalactic neighbors drop us a text tomorrow or centuries from now, we need a plan. After all, this could change everything we know about our universe and our place within it.